Michael Barbine. I'm a software test engineer working on a security client, FireEye. Does anybody know about FireEye here? All right, cool. We do security stuff. So what I'm going to cover in this talk is who I am, the products at FireEye and the team that I work on, the tools we use, the framework, and its design challenges, because we didn't have a framework for automated testing. We also, well, just to talk about the products because it gives some context into what some of the challenges were in testing a security product, because some of those things kind of have to hack yourself in order to test the security product. So I automated all the things at FireEye. I was a DevOps engineer hired on at Mandiant. We were acquired. I was supporting all of the Mandiant security products, which included an endpoint security product that kind of grew organically. It was startup, very startup. Worked in a closet, Costco tables, like just total startup. It was awesome. In my previous role, I worked as a systems engineer, network engineer, database engineer, and application developer. I wrote my first security application when I was 11 in BASIC to keep my siblings out of my computer. And I didn't know about BIOS password, but then I added that in there. It's just a funny story because as part of that, you can control break out of any BASIC program, right? So I popped the keys off and switched them around, all in break control, and that worked. So that was, throw hardware at it, right? Solve coding challenges. Before joining Mandiant, I would spend vacations at hacker conferences like DEF CON, ShmooCon. Those are ShmooCon's local in DC, by the way. I was working at Jenkins user conference in San Francisco. I was invited back for the London talk on a plugin on building Jenkins databases. All of my talks are how to do things the wrong way. So, because I don't.
Just go with it.
Yeah. I'm also a beta developer for Facebook's Thread Exchange, which is an Intel sharing platform. And I like to party. All right, so the FireEye stack and its threat protection platform. Hackers. Okay, so I'll talk a little bit about that. We have a lot of products. I work on the endpoint product specifically, but with the network platform, I just want to talk about this a little bit. I'm not trying to sell it. Basically, the network product, NX, will sit in your network somewhere, and when you download a file, it will pull it off the wire and sandbox it. So it'll run it in its own virtual machine. It'll see what it's doing, detecting 0 days, just finding out if it's bad or not. This is in addition to our intel, which is like, okay, we already know about this MD5 or whatever it is. It's bad. So we have to do similar things for mobile. We have a lot of intelligence. FireEye, Mandiant actually, when we were acquired, we were offered more money than what FireEye bought us just for our intel. This is not including services and products. We have really strong intel. We do forensics. So forensics encompasses a lot of things. We have a packet capturing appliance like Mollic would be an open source equivalent that they have all the kinds of stuff. But we just do full packet capture, full duplex, 20 gigabits a second. Pretty awesome. Sounds like a historian for anything that ever happened on your network, right? More, you guys have other stuff. What else? Okay, that's, same email, same thing. We're sandboxing that stuff and pulling off the wire. Endpoint, that's what's on, that's your laptop, right? Your desktop, all that stuff. It's cool. Look at this. All right, so HX is the name of our endpoint platform. It's a client-server architecture designed to detect and respond to targeted cyber attacks and zero-day exploits on the endpoint. I work on the X agent. That's the client, by the way. It's cross-platform, Mac, Linux, Windows. It lives quietly on the endpoint, sends data back to HX. So that's forensics, all sorts of stuff. Exploit detection, containment. Containment is where we roll. If we find something is bad and somebody, a human needs to do this, it can be automated as well. Basically, we'll just pull your endpoint off the network and we can do an investigation on that. We can whitelist things too, so we obviously whitelist our HX server so we can deal with it. And actually, it's actually a 1.0. We have an aggressive deadline. I started on this team in January. It was 2 people, well, at least on the testing side. We've been developing for a while. And it's a re-architecture of a legacy product. That legacy product was a Mandiant product called Mir, Intelligence Response. that grew organically because Mandiant started as a services company. You probably Sony, right? Everyone knows about the Sony hack. This is the tool that was used to do that investigation and find, back the hackers out, find out what they did, why, where they were, how it happened, all that stuff. That's this product. That's what we're testing here. So yeah, it grew out of, Mandiant was doing these types of investigations for a long time, since 2006. So the security engineers need a way to figure out, basically, they got a bunch of security experts. There's no tools out there to do forensic investigations at scale. So they decided to start a software company, a product organization within the company to, facilitate that. So we're doing automation of forensics and all that fun stuff. Awesome. All right, so let's talk about some of the tools that we use to build this automation framework that I'm talking about. How do you guys know about what FireEye and Mandiant is? All right. Okay, so on the X agent, NHX specifically, this endpoint product, we use VMware for our hypervisor. It's on-premise, all that. We also use physical and virtual hardware, or physical hardware. Yeah, right. So we use Artifactory to store our build artifacts. We use Jira for project bug tracking, test rails for test case management. Did anybody here use test rails? Artifactory? Yeah, Artifactory is pretty popular. Test rails is actually really awesome. It's built on Ruby on Rails. It's very lean interface, but it has a really strong API. So you can manage all your test cases in that really quickly in an automated fashion. I really like it. When fast support, but actually when you put in a request, you're actually sometimes you're talking to the CEO and he's just really nice. It's cool. Jenkins, CI tool, obviously. In this case, we're using it for test orchestration. Just running all my tests through it, right? Python for basically everything. That's, doing all the work, but not necessarily running the tests. I'll use it in the tests as long as it's not as long as it's a cross-platform test, because we are supporting Windows, and some of the things that we're testing aren't whatever I develop in Windows isn't going to work in Mac and Linux, because it's especially with forensics, it's totally different. But we use PowerShell batch for things like that, or a combination of all of them for whatever we need. Obviously, we're thinking long term whenever we need tests. And GitHub, in this case, to store our testing artifacts. All right, so I joined the team in January. It was a new team, new product, X Agent, pre-alpha, just very early. Everything was manual. Everything was manual. So I came from the DevOps team. I built the build pipeline. It was pretty much the same team. I just moved a few desks over. They pulled me onto the 1.0 project. They trusted me with that. So I joined the team, and I'm sitting down. I have to learn the product, more about the product than I knew before, and I'm like, so how do you test this thing? And the test engineer's like, well, just deploy your environment. We had an automated process for that already because I built that for them. So deploy my environment. It's every operating system that we support, and that's Service Pack and all this, And so I had a test case, or a bunch of test cases, and I need to test one of them, and this is what they're telling me. So I'm going through each of my virtual machines after I deploy them, and I'm running a test, and I go to the next virtual machine, I'm clicking on it, and after I run the test again, it'll take you forever to go through all of the operating systems and actually finish this test case, because you got to start somewhere, and that's where we started, and it was sad. It was just sad for me. So, but they pulled me on, so I could automate all the things and fix it, right? So, like I said, we need to test on all supported operating systems. That includes Service Pack, R2, SP1 for Windows, everything. So that one test case that is compounded by the number of things that we support because it's endpoint. This isn't a web application. It's not as easy to do. No offense, like some, Chrome, Firefox, and Internet Explorer. It's just it's that complexity, but then multiplied by, or compounded by everything else in the test. HX is a strong API, so we can do a lot of testing through that, but we can't really, we can't do everything. For example, we can say, okay, this data has come back, but is this data like what a hacker would do to, we have to imagine ourselves circumventing our own product. You know, if it's forensics, what can I do to like manipulate the data so that forensics can't be captured or hidden or something like that? You know, some sort of, you know, technique. So you basically have to hack yourself. So for example, the agent protection, what that feature does for X agent is it's preventing process injection, so hijacking the process. So how do you test that? Like, you can't test it through our web server and go back down because it's just not. Basically, you have to roll your own non-malicious process hijacking tool. So you have to roll our own hacking tools for that. Forensics, like I said, it's, you know, users that, or maybe even better, like a file. There's certain files you can create on a box that cannot be deleted or read. So how do you, you know, so those are some of the challenges. Exploit detection, that sort of stuff. So these are things that have to happen on the endpoint in order to test them. So you can't go through the server's API, pull that data back necessarily. You have to create scenarios in order to do this kind of testing. And in order to do that, we need to build a tool that is flexible enough to move between both high security labs for detonating real malware, exploits, development environments, and general QA. When we develop our software, we do it in a very high security lab. I mean, I can't go into too much detail. We were lucky enough to have them give me this talk, but it's a very complex environment. So it needs to be flexible to move between those. This whole framework needs to be able to move between areas within our life cycle. So we use the existing tools that were available in our infrastructure, so it's, you know, all the things I showed in the previous slide, things like that. And there's, like I said, there's something off the shelf to facilitate this kind of testing, really, unless you know of something you want to tell me, because I mean, anything that I can find online is already it's going to actually do more than just test the product. So in order to do that, we have to do some of the hardest parts first. I want to take this agent I have and I want to deploy it against our test environment, which is, you know, every operating system, all its different versions, service packs. I want to configure the environment through scripts mostly, but we have some CM processes in place. We may use Chef, we may not, but Chef's strong because it's cross-platform. So that already eliminates basically everything, most of the tools out there, because everything's focused on Linux only. And if all I had to do was test the Linux product, my life would be so easy. It's awesome. And yeah. All right, so we need to run some tests. We use Python mostly for that again. We write those results to a file. Python, we roll those results back to a server, and Jenkins is orchestrating all of this. We're analyzing those results, and then we revert the VMs back to a Delta, powered on snapshot of the VM, so a clean state before the agent's installed. So we rolled this, so we built this, this is what it looked like. It's hard to see. So this is my first time giving this talk, by the way, and in practice. So we just created this Jenkins project for that, to facilitate that stuff, to start. And let me just make a note that this is the testing that happens after our development, after our build. So this is after the build, the smoke testing, any of that. This is when it gets out of our high security lab and hits our QA labs. So when I say continuous test-driven development, this same process can happen inside of our development lab, but also for regression testing and feature testing and more hands-on stuff. So that's what I meant by the flexibility of that. So I need to deploy, run the tests, all that stuff. So I go to create a Jenkins project that kind of allows us to push those parameters into a UI that Jenkins provides. Now, we could create a new UI for this as well, but we haven't done that yet. So you select your install mode, and those options are install only, uninstall and reinstall, install and uninstall, I think that's it, or none, right? And none will just run the scripts, right? So it's already installed, something like that. That also helps us doing like install or upgrading from a previous installation or something like that, or running, you know, we're just kind of testing our tests, if you will. It's kind of flexible. This is where we started. So you select your installer file, your config, the target you're going to deploy, which is just basically a text file with IP addresses. It can be physical or virtual, doesn't really matter. A startup script which will run based on your install mode. It will run before your install, so that could allow you to maybe have a script that will create some, what would look like hacker activity or something like that, maybe run some exploits, see what happens, or we'll do that afterwards maybe, set your timeout period, and then a post-install script after it installs or uninstalls, depending on, yeah, there's a workflow here. There's an archive file if you want to upload a zip file that has a bunch of artifacts in it, some scripts files, maybe your exploits or your malware that you want to run. That'll detonate on the box. And then there's VHS checks, which basically will verify that the install completed, that there's files still there, files exist, things like that. So we have, and at the bottom here, there's a revert to VM or not, or revert to snapshot or not, and then a double button. So this is the Jenkins interface for this project. We call this test runner staging. There's test runner production, which is basically nothing. So, all right. So we built that, had to shop it around. This is a new process, it's a new team. They're used to doing things manually up until now, and now I want them to use this because I want them to write tests that work within that framework, within that process. Because while I'm finishing out the rest of it, which I will talk about, I need test cases to be automated. So make sure they run within that. When you kick that off, it'll deploy that job off. It'll deploy to 50 virtual machines. It'll install it. It'll test, assuming that they're all different numbers. It'll test all that stuff, and it'll bring the results back. It'll parse through your results manifest and send you an email saying, yeah, this is what passed and failed. All right. So we, shop around, start using it, test it out, make sure everything works. When a test passes, it says it passes, fails, it says it fails, everything's working properly. We can build up the rest of the framework while there's bad things happening. This is what our factory looks like. Everybody knows what that is. It's just kind of where we're storing all of our builds. We're only using the API for that nowadays. All right. So I store all of our test cases in GitHub, right? We have everything organized just like we do in test Rails by feature. Within the feature, we have version, and within the version, we have a folder within the GitHub repository for our test case ID. And this will all make sense in a second. This is what test Rails looks like. It's basically the exact same thing. These are our test suites for each feature. So GitHub and test Rails look exactly the same. This is going to make sense because
does that color mean something? The green boxes, are those good?
Yeah, I don't know what that means. I'm assuming it's good for now. It's probably the tests or it's the coverage or something like that. All right, so this is within an example test suite. These are all our test cases. We've got the version of the product. This is the install test suite. Okay. So what that kind of looks like within test Rails. And in GitHub, within one of those, this is an example test case. So we've got the test case ID here. It's the installer test suite. It's an upgrade. So that's a section of the test suite. We're upgrading from this version to the most recent version, and then this is some context on the command. So each test case has to have these artifacts. We've got the agent config. These are all the things within that UI that you used to upload, but now you can just keep kind of posting to GitHub. So, based on, it doesn't have to be all of them within that UI, but it'll know. This manifest file is actually what will be automatically passed to the Jenkins API when we're doing the end-to-end fully automated test. So I'll show you what that looks like next here. So this is what we used to look like, and this is what we're sending to it now. So it's basically a JSON manifest that has the name of the file within the test case. And this is going to get really interesting because, all we're doing now is I'm working within that GitHub, like a dev branch for my automated test suite. I'm working within the installer dev branch. I can actually write my test, add the installer artifacts or whatever I'm installing for this test case. I upload the archive.zip. I put it all in this manifest. I put it all in that test case folder. And when I check it into the dev branch, it's going to kick off that staging job. It's going to pass this manifest right to the Jenkins job. It's going to run the test and let me know if it passed or failed. Right? So I'm just writing tests now. Okay? When I check it in, if it failed, I refactor, I check it in again, run the test, let me know, okay, it passed, then I'll do a pull request merge to master. Okay? When I do that, it actually updates the flag in test Rails for the type to automate it. It's going to run every time there's a new build. So everything's automated end to end. When a new build hits Artifactory in our repo, it's going to automatically run regression, full regression. I told we get a staging branch when new tests checked in. I just said that. Test cases that are already running each new build. So checking the Artifactory. What happens next is it will trigger the Jenkins project. Jenkins will actually download all of the installers off of Artifactory. It'll then query test rails, say, hey, give me all of the, we want to do installer regression first because we want to make sure that everything's installing properly and all this other stuff. We're going to check out all the test cases that have the automated flag with in their priority. We're going to sort by priority. And because each test case and test rails has that ID, we can then query GitHub's API. And we want to pull in all those artifacts for each test case. So all that happens, it gets pulled down to a shared workspace in Jenkins. Okay, does that make sense so far? Maybe? All right. Okay, so we've got the test cases that we want to run. Maybe a whole list, maybe 1,000 test cases that we're going to iterate through. And we've got all the artifacts for each test case from GitHub within that repo in one shared workspace in Jenkins. And we're going to walk through them and iterate them. We can go one by one, or maybe two, and then two. We can scale up our environments that way.
I have a question.
Sure.
So when you deploy, like the actual final production, do you run a subset of this, or is that end-to-end that you would run?
When it's end-to-end, that will run as long as it's checked into the master. It will run from end to end, like the way that I'm explaining now. If it's in the dev branch, then it'll just run that one test. Right. So it's going to run everything from end to end. So once we have a list of test cases and the testing artifacts, we're going to run one by one. It's going to take all those artifacts and push them down to all the different supported operating systems. It's going to run those tests. It's going to bring it back. It's going to create. I skipped a part actually. We actually create a new test plan and test rails with a test run for each operating system and add those test cases to it. Because after we run the test, we actually pass, fail it, or set the status. So we have a list of test cases. We're running them against all these operating systems. We're using Jenkins to orchestrate all of this. So. Yes.
So what's the overhead on the systems as code is being checked in, branch, merge, lots of things are happening, different CentOS.
That's an excellent question. That's an excellent question. We monitor that. So actually, I just finished this. We ran. When we started out with 0 test cases automated. Now almost everything is automated from end to end. This past weekend we ran 1,517 tests. Automated from end to end within 2 days, and that's compounded by the number of operating systems that we support. It did not fall over, but I didn't measure everything. I measured how long it took to do the test rail operations, how long it took to do the Artifactory operations, how long it took to run the actual test. What else did I measure? Oh, I also hooked into the vSphere API, and I'm monitoring what ESX host that test ran on, how much hardware that VM had, how much hardware, like monitoring all the performance of the hardware and the virtual hardware and all those things. I've got a single pane of glass this whole process. And this week I'm going to try to run 8,000 tests. We don't have 8,000 tests automated, but I want to see where this thing really falls right in its face. I want to know where it's going to crash things, because then I can just throttle back from there. Start to look at, okay, well, we can't do this many tests on this host, so let's, maybe it's the Jenkins nodes that fall over, so maybe we can start looking at ephemeral nodes that just spin up on different hosts and be able to handle that. I just want to know where this thing falls down, because we released on August 25th. And we need to have this running continuously every week, every build, and maybe even every day as we do dev builds. That's why it's flexible enough, because I use all those off-the-shelf tools. I can move it between environments. It's not really dependent on any weirdness. It doesn't actually have to use VMware. It could use KVM Informant, it could use AWS, it could use whatever else, that other maybe product team is using, or, whatever. So
where do the other 6,500 tests come from? I mean, are those taking the current ones and just buzzing some of the current?
Yeah, so this weekend we may have 16 or 1,700 actual tests automated, but I'm pretty much just going to copy and paste them because they're actual tests. I just want to know where it falls down, because that's important for me to know, because I don't want that to happen when we are relying on it. I I can throttle it back. I want to be able to know where I can, where I don't want to push my system too hard. Yeah.
So you do have auto run on every commit, every change.
For
every test case that you change or
for
write.
every while the tests are being developed, and that runs in its own staging environment completely. So we have staging and VMs. We have it's basically its own infrastructure just for development, for test development. Yeah. So that's running several I'll check the test, it'll just run, but it's just one test, so I know we can handle that.
So we are dealing with, we have a similar setup, but for development, not for testing. But we have setup, and then we are dealing with branches, like if you're doing feature development, then you have a feature branch. And where do you stop? Like how do you make sure? And you add database to the mix, and it complicates the thing.
I guess we'll cross the bridge when we get there. Right now, this is just kind of where we are. It's kind of basic, and we have lots of tests, but we're not, we have to obviously do our versioning later, everything like that, because we're not even at 1.0 yet. We're in beta. So
it seems like this is independent of the dev team checking in. So the dev team
this is
checking
totally
in.
independent of the dev
Everybody
team.
else,
Yeah.
it's building. They have their own tool to do the build.
Yeah.
Those installers are going in Artifactory.
Yeah, we don't care once it hits our Artifactory instance. They have their the development side of things. They're using TeamCity to do the builds.
Okay.
It's in a high security environment where they can't have source code in their laptops or anything like that. It's awesome. It's like you have to go into a room to do the builds and turn a key and scan your eyeball, all this crazy. Anyway, so once all that's done and they actually have a build and it hits Artifactory, their instance of Artifactory, they have it gets pushed. It's one way, it's it's walled off and through VPNs, and eventually hits our QA lab, and that's where you are. That's where you are kind of more complex for regression testing.
Do you have more slides? I think we've gotten to a lot of questions.
I don't think that I have. That's good. No, that's perfect. Yes.
I'm curious about your developers. How do they develop in that those environment? And how do you develop in your environment? It's the same approach?
I can't talk too much about that, but in my environment, it's because it's already built and there's a source code for the actual product. There's less security because we care a lot about security at FireEye, but we care about it more and it gets more complicated, more difficult. Source code is obviously our bread and butter, so we want to keep that walled off. So if you can measure any security measure that you ever put in place, it's in place in our development labs. And then once it hits this kind of QA, what are you going to do? Steal our agent? What are you going to do with that? It's really just kind of, you can't really do a whole lot with it by itself. So, I can't go too much into detail on how we do our development. It's kind of.
I was curious about the feeling, about how you can develop without using some external repositories. Like you develop something in Python, you will probably pick using an external repository. Like you will, I don't know, probably do DevOps. You need Chef, you need a supermarket or something. In Java, probably you need a Maven, something.
Yeah, we have a lot of those things in our QA labs, though. I don't know what they have in the dev labs. You can do code like that. Yeah.
So you just get a black box binary and you throw all this shit at it.
Yeah, now I do. When I was in the DevOps team, I was a little more involved in some of the other stuff, but I switched to take on this project.
So,
it's awesome.
How would you generalize from some of this experience for those of us who are not writing security software but maybe want to throw security crap at our web app or Chef client or Chef server to see how it stands up in an automated fashion? Or is that too far from what you're actually doing?
Well, that was some of the challenge of developing this, is that we were testing a security product, but it was a desktop application really with no UI, and it runs as a service, and it's just and it's actually designed like malware. I mean, it's doing forensics, it's doing, it's doing a lot of things at the kernel level, things like that. So you have to do a lot of a lot of hack-foolery to test it. But the way that we tested it was very off the shelf. It's just, we're just using all these tools, and I use Jenkins to orchestrate everything. I mean, we're not at the point that where we're doing real world configurations where we want to like stand up a SQL server or, you know, and run our tests on that to see how our, you know, how some of our, the features of our product will stand up against sharing event buffers or something like that. You know, there's some weirdness because that could cause issues for us. But, you know, some of the all the tools I use were off the shelf. I'm just hitting all these APIs and using Jenkins. So really, the way that I did it could be used for any desktop application.
So it's mostly handling all the permutations of
Right.
patch levels and.
Yeah, patch levels, different ways.
8.1, Windows 7.
Yeah, and there are ways to install the agent for our product because we have features like disguise where it doesn't show up in average programs or at the equivalent for any other maybe OS X. It doesn't show up anywhere like that. You can rename the executable, rename the service. So that gets really complicated when you're doing upgrade regression because you have to figure out what this product is you're not installing first. So that gets a little challenging too. You know, because we want to hide from the hackers. You know. That kind of stuff. Yeah, it gets really challenging. So, yeah.
When you develop tests locally, what VM are you using typically? And then what are you using to manage your virtual machines? Like typically Vagrant or some other?
I'm using, well, I have my own VMs in our environment, but we're using VMware. So,
Okay.
yeah, to deploy those, we're just hitting the vSphere API, usually the PowerShell API. And we have Jenkins jobs also that just hit the PowerShell API, the vSphere API, deploy whatever we want. And again, easy to use interfaces where you select what you want, or you pass it a manifest file and say, this is what I want, and it'll just deploy them for you.
And you just have like 50 different boxes that you can deploy.
Yeah, and then we also have things that are like to destroy after a certain period of time. We build in things so that you don't have to sprawl. You know, if the test fails, you want to keep it. If it passes, you can destroy it. You know, basically just build those into check boxes and little things just to, but those check boxes are easy for someone that just wants to do one-off deployments. But if you wanted to add them to your JSON manifest that you're passing to the Jenkins API to run your jobs, it's just a matter of true, false, you know, yes, no. And you should know that going into your test because you probably tested it first manually. Yeah, so. Yeah.
Speaking of all that manifest business, why didn't you use like some of the usual ways to make a Jenkins job, like the Groovy script, or I don't know. Why'd you go down this road?
Probably lack of knowledge in
Okay.
certain areas. I'm on the testing side, not the DevOps side anymore, so I have to be understanding of like where my focus is getting the product tested. So,
Sure.
you know, building those things out, you know, just wasn't on the top of the list. Again, August 25th is our deadline, so I have to be very careful about what I do. So yeah, I took some shortcuts, but it works. And we can always replace some of those things with, you know, Groovy scripts make it a little bit more flexible or more intuitive in the process. So, yeah.
So are you running all those different environments, all the tests on them serially, or are you kind of exploiting all the environments out at once and testing them all at the same time?
No.
As part of your jobs? Or?
So in some cases we're you know, just deploying a bunch of it at the same time, but actually a lot of the tests are static environments. They're just, okay, I have environment 1, which with every operating system, with a clean snapshot, so we can revert back to that snapshot and it's powered on the clean state. And so after the test is run, we're just going back to a powered on state. It actually happens really fast. We're exploring areas where, as we start to scale up again, I want to see where this thing falls over, because a lot of my concern at one point was, where do reverting is probably going to be the slowest part of it, depending on the data store. So what happens when we're reverting back 150 static VMs, and then it just goes to a crawl? So the solution to that we're actually testing right now is reverting the data store. So it's one snapshot back. So we do the 150 tests, they all come back, they pass the tests in their respective runs, and then we revert the entire partition instead of each VM individually. And that's actually a lot faster from what we've seen so far, and I can measure that. So as we could scale up, we kind of determine how we do these things.
What is that timeline? Like 1,500 test cases?
What's that?
How long does it take you to run the 1500 tests?
This past weekend, so we've done one test like that.
Yeah.
This, it took from Friday at 6 p.m. until Sunday 9, something around there. Yeah. Yeah. We have a dedicated cluster for this too. So it's 2 ESXos beefed up, like Dell, I don't even know what it is, but it's beefy, yeah. And we're just running this stuff on that dedicated. It's not a basic cluster. Yeah.
Thanks, Michael.
Thanks, yeah.